Today we are talking about the addition rule and conditional probability. Okay? When I told you guys on Tuesday, you have your basic probability and it can go on from there. Okay? This is another aspect to it. Okay? Once we get to this point, we're done with probability. Okay? Then we'll be going into the statistics part of this unit. Okay? We'll leave all the other probabilities for your next class. But today we're talking about the additional rule and conditional probability, which is going to basically help you be able to determine the probability of different events happening. Not just you have this very simple spinner that you're spinning and trying to figure out, the probability of landing on the strike section. I am talking about, given that it lands on the strike section with the probability that it landed on the 10th spot. I'm talking about stuff like that. Okay? We're talking about that today. So we're going to start with the addition rule paper, the blue paper. Okay? Starting off with the addition rule. What the addition rule basically says that when you have two events that have no effect on each other, the probability that A or B will occur, the following formula, okay? You have the probability of A or B happening is going to equal to the probability of A plus the probability of B minus the probability of A and B. Example 11, we could have used this addition rule, okay? So, A and B are two events that happen, okay? There are two events that happen, okay? So like in your homework, that they said yes and that they were a male. We could have used the addition rule to answer this question, okay? A represents the probability of them saying yes, and B represents the probability of them being male. We had to subtract the fact they said yes and they were male. Okay, so remember the 14 that overlapped? Remember we had to take that out? We could have used the addition rule here to do that. But like I said, it was a segue into today's lesson. Last problem, segue into today's lesson. Okay? There are symbols that are associated with the word or and the word and. So I am going to rewrite this using the symbol notation because there are a few problems in our whiteboard practice that are going to involve the symbol. Okay? And I don't want you to be confused. The word or can be written with the U. Okay? And I'm not talking about like the letter U where you bring down like that tail end for the U. It's just a little swoop up. And then the and is the opposite. It looks like an N, but it doesn't have that little straight part there to represent the N. Okay? So those are the symbols that are associated with or as well as with and. Okay? Essentially, yes. So you use this when you have basically like an overlap. Here's another example. Yes, okay? Let's say you have a deck of cards, right? 52 standard card deck, all right? And I want you to tell me what is the probability of picking a heart or a king, okay? What's the probability of picking a heart or a king? So A would represent the heart, B would represent the king, but if you think about it, if you know cards, is there a card that's a king of hearts? So then you would have to take away that one that represents the king of hearts because you basically counted it twice when you counted it with the hearts and with the king. You see what I'm saying? So how many hearts are there? There are 13 hearts out of 52. How many kings are there? There are 4. But you counted that one card, that king of hearts, twice. So if you subtract that one card, you're taking care of, the fact you counted it twice within your hearts and your king. Okay? So then the probability of you picking sorry, I should have plus. Probability of picking a heart or a king 16 out of 52, and of course that reduces to 4 out of what? 13. So that's an example that you can add in with these notes here, okay? There's two that we are going to go over together, and then there'll be some that you'll do on your whiteboard just after we go over conditional probability, okay? So let's look at an example, okay? In a math class of 30 students, just changed this to 20 and made it more realistic to this class of 19. So here we go. In a class of 30 students, 17 are boys and 13 are girls. On a test, 4 boys and 5 girls made an A grade. If a student is chosen at random from the class, what's the probability of choosing a girl or an A student? Do you see what your two different events are? What are your two different events? Girl and A student. Weren't there some girls who got A's? So you do have to take into consideration that there is a girl who is also an A student. So this is where the addition rule comes into play, because you're looking for the probability of being a girl or an A student. So I'm going to add the first two probabilities and then subtract the overlap. Subtract the fact that I'm counting them twice when I look at the total. How many were girls? 13 out of 30. How many were A students? 9 out of 30. How many of them were girl A students? 5 out of 30. So this is how you set it up using the addition rule. 13 out of 30 plus 9 out of 30 minus 5 out of 30, which is a total of 17 out of 30. Can I reduce that? Does this make sense? Okay. Look at the next example. A single six-sided die is rolled. How many options is that if I roll a six-sided die? I want the probability of rolling a number greater than 3 or an even number. What are my two events? Greater than 3 or even. Is there an even number that's greater than 3? What is that number? So, using the addition rule, writing it all out for those. How many numbers are greater than 3? That's 3 out of 6. How many of them are what? How many are even? Because we are looking at a six-sided die. There are 3 even numbers. How many are even and greater than 3? 2 out of 6. So it's 3 plus 3 minus 2, which does reduce down to 2/3. Okay? So that's the probability of picking a number that's, or rolling a number that's greater than 3 or an even number. Remember, probability should always be less than what number? And greater than? Yeah. Very good. Questions on addition rules?
It's not twice, you can twice before you add and subtract, then you have to find how many are in.
Exactly. Now realize this addition rule can be used not just to find the or part of this formula, but it can be used to find any part of this formula, because this is nothing but an equation, okay? So I could actually have given you the probability of like this part here of the or. I could have given you the probability of A and the probability of B and actually define this part, the back end, okay? So realize it's not just for finding or, it's for finding any one of these pieces, okay? Equation. There we go. Let's look at the conditional probability. Conditional probabilities, okay? Let's talk about what conditional probability is, okay? This is when you have, this is when you're not looking at the entire possible outcome, okay? You're only looking at a particular set of outcomes out of the total, okay? So, this right here, which you see beside the words conditional probability, is the notation that indicates conditional probability. Okay? The vertical bar between the two events indicates conditional probability, which basically means the probability of B occurring, so event B occurring, given that event A has already occurred. Okay? That's what that notation means. It's the probability of B occurring given that A has already occurred. Given that are like two like key words when you're looking like say like a word problem that would indicate conditional probability. Okay, given that those are your key words. The formula for conditional probability is as follows. So the probability of B given A is equal to the probability of A and B happening over the probability of A. And of course, you know, you can use the and symbol, the N looking symbol. That is conditional probability. So no longer are we looking at the entire sample space, okay? No longer are we looking at all 52 cards, okay? Maybe we're looking at only the red cards and finding out the probability of, you know, given that we only want hearts or diamonds, what's the probability of getting a face card, okay? So no longer are we looking at all 52. No longer are we looking at everything. We're only looking at a certain set within that. Okay? Look at an example. Okay? Two cards are drawn. The first card is a 3. Okay? Two cards are drawn. The first card is a 3. What is the probability that the sum of the two cards you draw will be an 8? Okay? Let's start at the basics. Says the first card is a 3. Are we going to put that 3 back in the deck and pick a second? No, we're going to take it out. Okay? So how many cards are we looking at now? How many cards are we looking at now? 51. We're looking at 51. Now, what is the probability that the sum of the two cards you draw will be an 8? Now, 1 is a 3. That means I can only add one number to 3 to make 8, right? A 5. That is how many 5 cards in the deck? There's 4 or 5 cards in the deck, okay? So, what's the probability that you draw? The sum of the two cards will be 8. That's 4 out of the 51. Not 52, because we took out this 3. This right here was the first card, so we had to take that out.
Is that 8?
Hmm?
Is that like 8 you already have?
Well, it depends on what, like what something. So this is like more like the basic probability problem. It's like more your basic probability. This first one was. Now it's saying, what is the probability that both cards you draw are odd? Both cards you draw are odd. So, kind of put away the fact that, you know, a sum is 8. We're not looking at that anymore. Now we're looking at the probability that both cards you draw are odd. What are your odd cards?
1, 3, 5, 9.
Wait, time out. Is there a 1 card in a deck of cards?
No.
There is an ace, but ace is not a one card. It's an ace card. So can we consider the ace card? Can we consider the ace card? No, we can't. Can we consider the jack? The queen? The king? No, we can't. Even though, yes, in certain games you play, they represent 10 or 11 or 1, depending on which game you're playing. We're looking at a standard 52 card deck. So really, truly, we're only looking at our numbered cards, 2 through 10. Out of the cards that go 2 through 10, how many are odds? The 3 cards, the 5 cards, the 7 cards, and the 9 cards. And we have those 4 cards in 4 suits. So how many is that? 16. Okay? 16. Minus 1, because the first card that we drew was a 3. So really and truly, we don't have all 16 cards. We have to take away the 1 3 card that was drawn first. So really and truly, the probability that both cards are going to be odd is going to be 15 out of how many? 51. Okay? Can that be? Yes, they are both multiples of 3. So what's 15 divided by 3? And what's 51 divided by 3? 17. Okay. What is the probability that the sum will be prime? We talked about this. Let's take a look at our prime numbers. Let's list those out just to make sure we're not missing any. We got 2, 3, 5, 7. I was wondering one of y'all was going to say 9. It is 11. It's the sum. Can I add something to get an 11? Can I add 2 numbers to get 11? 2 card numbers to get 11? A 3, 13 will work too. What's the next prime number? 17. But considering that my first card is a 3, I need the sum to be prime. Is there a number that I can add to 3 to get 17? No. So these are my only prime numbers that I can work with. And actually, I can actually take out 2 and 3. Because of what reason? I can't add anything to get a 2 if I already have 3, and there's nothing I can add to 3 if I'm dealing with 2 cards. Okay? So I still have this first card. True, but these are like our prime numbers. We're trying to see which cards that are numbered cards can. Yeah, these are the sums. So we're basically trying to figure out what cards can we add together to get a prime number. How many of those? Okay? So, if my first card is a 3 card, what other numbered cards could I add to the 3 cards to have a sum that's prime? 2. I could add 2, the 2 card. Yeah, let's write this down over here. I could add a 2 card. That gives me 5. I could add the 4 card. That would give me 7. And I can add the 8 card. That would give me 11 for the sum. So the numbers underneath represent the sum, just to double check behind you. Anything else? Okay. So I can add the 2 card, the 4 card, the 8 card, the 10 card to get a number that is prime, a sum that is prime. How many of those cards do I have? 4 of each, so that's 16. So that's going to be 16 out of 51. There's 4 cards in each, so that's for hearts, diamonds, spades. Terrible. Okay? All right? Open it up. We got some fast food places. I guess a survey was taken where people had eaten there in the last week. People have not eaten there in the last week. We're going to let A be the event that someone has eaten there last week, and B be the event that somewhere serves hamburgers. Okay? And we're going to find those 6 different probabilities. Okay? So, the probability of A represents the event that someone has eaten there in the last week. Okay? How many people have eaten somewhere in the last week? Okay. 1 plus 5. 6, 10, 20. How many? 27. 27. This number comes from the total in the ones who've eaten there last week. Okay? How many people total are there? 37. Confirmation. Trust. 37. Okay. So 27 out of 37. That is the probability of A. The probability that someone has eaten there in the last week. There is in one of these places. Let's find the probability of B. The event that someone they like somewhere that serves hamburgers. Let's make sure we all know which places serve hamburgers. Who knows? Maybe y'all don't eat out. Does Jersey Mike's serve hamburgers? Huh? They sell subs. Mm-hmm. McDonald's. Yes. Yes. They serve burgers. Arby's.
Yes. I'm pretty sure they do have hamburgers. I don't know. I got a cheeseburger and I hated it. Cheeseburger from Arby's? Yeah. Okay, that doesn't sound right.
That doesn't sound right at all. Wendy's.
Yeah.
Popeyes. No, they serve chicken. Subway.
No.
Checkers.
Yeah.
Yes, they do. Culver's.
I think so. It's like chicken. It's chicken and ice cream.
It's like it's like what
A diner?
it's kind of like what Dairy Queen is,
Wow.
but it's like a different version. So like they serve ice cream and like that's their primary thing, but they serve like a hamburger, which is random. Okay, it's like Dairy Queen. I don't understand it. You serve ice cream. Why do you have hamburgers? Chick-fil-A. No. Jimmy John's.
No.
Jimmy John's is a sub place.
Cold stuff.
Freaky sweet fat. All right. So now that we know this, we're looking for the probability of someone like somewhere that serves hamburgers. Okay. How many people is that? Okay. What numbers are you adding?
Oh, no. Oh, you have to add the other, both sides.
You have to add both sides. You have to add the 5 and the 2, the 0 and the 1, the 4 and the 1, 4 and 1, 2 and 0. Okay? Because they didn't specify that they had eaten there last week. They just said go somewhere that.
20 out of 30.
So that's 20 out of 37? Good stuff. Okay. Before we do this one right here with the line, we're going to do the and one next. Okay? And we're going to do it. So when you're looking for the probability of A and B, that means you're looking for the number who had eaten there last week and like somewhere that serves hamburgers. How many? No, they're not independent. They can't multiply. It's 15 out of 37. Because think of it like this. These were all the people who were eating there last week. All of these people. And then the purple represents those who like somewhere that serves hamburgers. So if you're looking for both of them, eating there last week and like hamburgers, you want the ones that are circled in both red and as well as in purple. Does that make sense? You would not multiply those two probabilities because these are not independent events. It only works if they're independent events. These aren't independent events. But now that we have that all done, we can actually do these next ones that have the line involved. Remember, the line indicates conditional probability. Okay? And if you look back at the formula, the probability of B given A is equal to the probability of B and A all over the probability of A. So I'm going to rewrite that here. Don't we have both pieces of information? What's the probability of B and A? 15 over 37. What's the probability of A? 27 over 37. You have a fraction within a fraction. What do? Keep, change, flip. What happens to the 37s? They cancel out. So you are just left with 15 over 27, which reduces to 5 over 9. So the probability of B given A is 5 over 9. What does that mean in words? That basically means you just found the probability of someone who likes hamburgers given that they ate one of these places last week. Okay? So another way you can say it is given that someone ate there last week, what's the probability they chose a place that serves hamburgers? You just found that out by doing the conditional probability. Okay? What if it goes the other way? Let's look down here at the bottom, right here. Bottom corner. The format is a tad bit different. How does that change your formula? It's going to be the probability of A and B over the probability of B. Yes, it does matter what is following the bar. So what follows the bar is the condition. So given that they ate hamburgers, what's the probability that they ate there last week? Ate somewhere last week. So you do the same thing. You take the probability of A and B, which is 15 over 37, and you divide it by the probability of 20 over 37. But another fraction within a fraction means I have to do what? Keep, change, flip. 3/4, because the 37s cancel out, and you're left with 3/4. That's how conditional probability works. Okay? Whatever's the condition, which is what comes second in that setup, the denominator and the intersection on top, or the and on top. I'm gonna run out of space here. I should have done this on a different slide. Now I need the probability of A or B happening. I did that so fast. You sure do. You use the addition rule. Okay? Everybody catch that? It went by really fast. This one right here, this is the addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And you have all three of these pieces. A, I just scrolled up, was what? B, P, and A and B. And that is, so that's the probability that they ate somewhere that liked hamburgers or ate somewhere last week. All right. Look at the next side. Given the probability of A and B is equal to 0.5 and the probability of A is 0.75, find probability line A, probability of B line A. Remember that line means what? A is the condition. The full notation represents do I have all these pieces? What's the probability of B and A? 0.5. What's the probability of A? So all you have to do here is divide. What is 1/2 divided by 3/4? It is 2/3. So it's 0.66666 repeating. That does convert to 2/3. If you choose to use the decimal. What? Thank you. 3 significant figures. 3 significant figures. 3 significant figures. Look at the next one. We're given, this time, the conditional probability and the probability of A. We need to find the probability of A and B. So we can use the same formula as we did for the first one, but this time, we're actually plugging in for this side. What is that? 2/3 equals, or you do 0.25, you can do 1/4, either one. How do you solve this? Well, multiply by 1/4 because you're trying to get rid of the denominator. That turns into what? 1/6. It's too bad. You just gotta get the hang of it. You gotta get the hang of it. Maybe just put shortcut rules. This one down here. Excuse me. This one down here. Question? Because then it's going to be 2/12 and everything. What about this one? You have to do 1/8 divided by 2/7. Still using the same formula that I wrote down in the very first one. Make sure you do what here? Keep, change, flip. And that, dear students, is conditional probability. Okay? Make sure that you use the formula correctly. Okay? We are going to practice a little bit.